Okay, do you guys remember what is this line called on a circle? Radius. What's this line called? Diameter. It goes all the way across through the center, it's the diameter. What if it just goes from one point to another point on the circle?
Chord.
Chord. What does circumference mean?
All the way around.
Yeah, it's kind of like perimeter, but for circles. It's how far around it is it. Do you guys... You guys remember, does anybody know this formula for the circumference?
Diameter times pi, or radius times 2 times pi.
Right, diameter times pi, or 2 times radius times pi. Why do those both work? Because a diameter, if you think about it, is just made up of 2 radii. Radius plus radius equals diameter. Does anybody remember the area formula for a circle? Pi r squared. So that means you have to do radius times itself times pi. Okay, the next thing is sector area, but first we need to talk about what is a sector. I didn't draw that very well. A sector is a portion of the circle that's outlined by 2 radii. So basically it's like a piece of pie. So how could we possibly, oh, by the way, you guys see this little symbol right here? It's a Greek letter called theta, and it's usually used as a variable for a central angle. Theta, T-H-E-T-A.
What letter does that replace?
I don't know. I don't know Greek letters that well. Anyway, theta, and so whatever this angle is right here, that's what theta stands for. So maybe 60 degrees or something. Of course, this would be like a radius. From here to here, on the edge of the sector, that would be called an arc. So it has a length. The sector has an area, like how many square inches fit inside that, or whatever. So how do we find sector area? What you do is you find the area of the entire circle, pi r squared, and then you take that times the fraction of the circle that the sector is taking up. What fraction of the circle does the sector take? Well, a full rotation here would be 360, so it's theta out of 360. That's what fraction it's actually using. So that's the sector area formula. Pi r squared times whatever the central angle is, theta, divided by 360. So that last thing was, hopefully you kind of remember at least the circumference and area formulas a little bit. The sector area was, that's a new thing for us. There's also a formula for arc length, but evidently the book's not going to do that. Okay, I think we're ready. We're ready to rock and roll. On page 335. Okay, number 1 says find the circumference and area of each circle. State the exact value and decimal approximation to the nearest tenth. What does tenth mean?
The
First decimal place. So what they mean by the exact answer is they mean leave pi in the answer. Pi cannot be written exactly as a decimal number. So what they mean is write the answer with pi in it and then change it to a decimal and round it off. So we're going to have 2 circumference answers, 2 area answers. Okay, on number 1, how do we find the circumference? 6 is the what? Radius. So we need to do 2 times 6 is 12 times pi. So it's, the circumference is 12 pi. That's the exact answer. They also want the decimal for that, which we're going to round to the tens place. So you guys need to plug that in your calculator. 37.7, did you guys confirm that? I guess we probably should label it also. It says inches on this one, so 37.7. Would it be inches or inches squared? Uh-oh. Alright, that's the circumference. Then how do we do the area? We do radius squared, so 6 times 6 is 36 times pi. So 36 pi. Which is about
113 inches squared.
113 point what?
Well, I think.
So, okay, here's the thing. Some of you have or probably most of you have a pi button somewhere on your calculator. That will give you a more accurate answer. If you don't have the pi button, you can use 3.14. Your answer might be a little bit off of this, like you might get 113.2 or something. But anyway, that's an area, so I'm labeling it inches squared.
Is it okay if we don't get the 0.1 because I've just plugged in 3.14 and I got.
If you're close, I'll give you.
0.04.
If you're close, I'll give you credit.
Okay, thanks.
Because if you have to use 3.14, you're going to be a little bit off of what the book says. It's a little less accurate than the pi button. Number 3, 9/2 square root of 3. So, oh, by the way, on number 2, what's the difference between number 1 and number 2?
It has the diameter.
Yeah, right. 11 is the diameter, not the radius. So if the diameter is 11 on number 2, then what's the radius?
5.5.
5.5. 11 divided by 2 is 5.5. So just keep that in mind when you do number 2. Number 3, the radius is 9/2 square root of 3. So to find the circumference, we need to do 2 times 9/2 square root of 3. A lot of your calculators can do that, but basically the 2's cancel out. So it's just 9 square root of 3 times pi. I'm going to put the pi in the middle because if you put it at the end, it looks like it might be under the square root. But we do need the decimal for that, so somebody needs to plug that in. Anybody get a decimal? 49.0. The reason you might want to put 0.0 is because you're showing that you're being accurate to the tens place. Not that we're not rounding it to 49, we're actually rounding it to the tens place, so anyway. The second part. So, 9/2 square root of 3 needs to be squared. So in other words, multiply by it. So you could plug it in with your calculator, like something like this, and square it. It's not too hard to do that by hand because 9 times 9 and 2 times 2, that would be 81 over 4. And then, do you guys know what square root of 3 times square root of 3 is? Square root of 9, which is 3. Anytime you square a square root, it just becomes the normal 3. And if I multiply 81 over 4 times 3, I get 243 over 4. what did I forget?
Reduce.
No, it doesn't reduce. I forgot the pi. So this would be the circumference, or sorry, the area. And can you plug that in the calculator?
$190.8.
190.9 is what the book put. So that's one of those things, if you have the pi button, it'd be more accurate. That's an ugly little line there. That is feet squared. Forgot to label it. No, too. Might be hidden pretty well. Possibly, some calculators might not have it.
Yeah, sometimes you have to press like a shift button.
Yeah. They're hidden pretty well sometimes. I feel like
What they?
okay, number 5. Okay, kind of the same thing. They just didn't draw a picture for us. If on number 5, if the diameter is 4, then what's the radius? 2. Yeah, a radius is always half the diameter. So I'm just going to put these answers in order. 2 is the radius. Okay, if the diameter is 4, what's the circumference? Right here. It'll be 4 times pi. Or 2 times 2 times pi. So 4 times pi. So we're just going to leave that alone on this one. It didn't ask for the decimal answer, so we'll just call it 4 pi for the circumference. If the radius is 2, what is the area? 2 squared times pi. 2 times 2 is 4, 4 pi. The circumference and the area are the same only when the radius is 2. That's the only time it happens.
Is it okay if I finish it out? The 4 times pi?
No, just go ahead and leave it with pi. Because that's how the book says it, so when we're grading, that's how we're going to say it. Number 7. Okay, if the area is 0.04 pi, how can we go backwards and find the radius? Okay, radius squared times pi should give us the area. So basically the radius squared should give us 0.04. So if the radius, right. So in other words, go backwards by doing the square root. What's the square root of 0.04? 0.2. Is 0.2. So that'll be our first answer on 7. The radius is 0.2. If the radius is 0.2, what is the diameter? 0.4. It's just double that. If the diameter is 0.4, what's the circumference? 0.4 pi. And then they gave us the area, so that no. Okay, number 9. They give us the circumference is 30 pi. If the circumference is 30 pi, then what is the diameter? If the circumference is 30 pi, then what is the diameter? If the circumference is 30 pi,
15.
no.
No.
Okay, you guys are making this too hard. If the circumference is 30, diameter times pi is the circumference, right?
Oh, 30.
So if the circumference is 30 pi, what must the diameter be?
30
Now, notice when I write that answer down, I'm putting it as the second answer, not the first one, because the first one's supposed to be radius. If the diameter is 30, what is the radius? 15. Half that. If the radius is 15, how do I find the area? 15 squared times pi. Does anybody know what 15 times 15 is? 225 pi. Yes. We skipped the circumference because I already had that one. Okay, number 11 on the next page. So you guys see the pie chart there? Does anybody, it says given the U.S. federal spending for 2015 was blah, blah, blah. You guys know how to read that big number? Okay, the first set of zeros is the ones place. The second set of zeros is the thousand. The third set of zeros is the millions. The 760 is in the billions, which means 3 is in the trillions. So you guys know our, I don't know what our national debt is, probably about 30 trillion or something.
No, it's 34 trillion.
34 trillion. So anyway, they're saying this was the budget for 2015 by the federal government. 3,760 billion. So we found out in the other class that the calculators aren't big enough to put in like trillions. So what the calculator does is it gives you a answer in scientific notation. You guys remember scientific notations?
Yeah, so it'd be like times 10 to something.
Yeah, like 3.7 times 10 to the 12th. This would be like 3,700 billion. It means the decimal moves 12 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or whatever. So that's ones, thousands, millions, billions, trillions. So if it's times 10 to the 12th, that's actually 3 trillion. If it was times 10 to the 11th, that would be like 370 billion. Anyway, we'll figure it out. It's kind of a pain because it doesn't fit on the calculator. Number 11. So what it's asking is determine the central angle for each sector and the amount of federal spending in each category. Rounded to the nearest 10 billion. So on A, welfare is the dark orange, I think it's brown actually. You guys see the welfare?
The 10% one?
10% piece of pie. So the first question is, what would the angle for that piece of pie be? Now, how many degrees are there in a full circle? 360. So what we need is 10% of 360. How do I find out what 10% of 360?
360.
Good job. You guys remember some stuff from last year. 10% is 0.10 or 0.1 of means times. 10% of 360 is 36 degrees. So that's our first answer. The next answer is how much money is that? How much money did they spend on welfare? So that would be 10% of the 3.76 trillion. So you have to do 10% times 3,760 billion. That. When you multiply by 10%, you're really multiplying by 1/10, which is like dividing by 10, which is like moving the decimal one place to the left. So the 3.76 trillion becomes 376 billion. That's billions, millions, thousands, ones. $376 billion. It's a lot of money. And that was A. A lot of work for just an A. But now that we know the pattern, shouldn't be too much problem. So it says defense. Defense is in red, which says 22%. So how do I figure out what the central angle would be? Yes, 22% of 360, so 0.22 times 360.
$79.2.
79.2 degrees, all right. And then we need what is 22% of the 3 trillion. A lot of your calculators have functions where you can go back up and replace the numbers that you put in for the last problem. They're kind of different on every calculator though.
Um, 8.272 times 10 to the 11th.
Okay, yeah, times 10 to the 11th. What that works out to is 827 billion. So it's 827 billion, 200 million dollars.
Can you have to put it in that, or can you leave it in scientific?
Let's not do scientific because the book actually just wrote 827.2 billion. It's probably better if we just write it out as a normal number. Nobody talks about how much money we spend in scientific notation. The only time you really want to use scientific notation is pretty much for science stuff, like how many cells are in the body, how far is it to the next galaxy, that kind of stuff. What's the probability that you'll pass this class?
0.
1 in 327 quadrillion, 204.
You have high hopes in me.
So you're saying there's a chance. All right. C, healthcare. It's taking a while. Healthcare is the bright orange one, so it's 27%. So we need to figure out what is 27% of 360. 0.27 times 360. 97.2. Okay, mixed up the last one with this one. And then we also need what is 27% of 3,760 billion.
Times 10 to 12.
So since it's to the 12th power, that's like 12 spaces after the 1, that means it's actually a trillion. 1 trillion, 15 million. 200. 1 trillion, 15 billion, 200 million. Dollars. That's a lot of trillion on healthcare. Healthcare is expensive. And this is back in 2015, so it's worse today. Education is the 4% one. kind of small. So 4%, to change that to a decimal, you have to move the decimal place twice. So it's actually 0.04. So what's 0.04 times 360?
14.4 degrees.
14.4 degrees. And what's 0.04 times the big money?
1.504 times 10 to the 11.
Okay, if it's to 11th, it's basically in the 100 billions place. 154, is that what you said?
1504.
1504. So $150 billion. Kind of a long problem. I'll probably count each of those as a point. Give us some more points on that. Number 13. Okay, so on this one, it's asking us to find the sector area. So we're going to be using this formula right here. Pi r squared for the circle area times the fraction of the circle we're actually using, which is the central angle over 360. Okay, so on number 13, the radius is 2, so I'm going to do 2 times pi, so 4 times pi, times the central angle theta over 360. The central angle is 55, so times 55 over 360. Probably what you would want to plug in your calculator is 4 times, here I'll write it with the time symbol, 4 times 55 over 360, and then just put pi on the end of your answer. We're not going to be multiplying the pi out. And what you would get basically is that reduces to 90. So it would be 55 over 90.
I thought the radius was 2.
It was. So when you're doing, so we did 2 squared is 4.
Oh, okay.
Don't forget the pi. They didn't give us, well, this is units squared, but you don't have to label it. Oh, that reduces, sorry. Those are both divisible by 5.
11 over 18.
Yeah, 11 over 18. My bad. Okay, so this one doesn't give us the central angle. So I know the radius is 4, so 4 squared times pi, 4 squared is 16, right? So 16 times pi times theta over 360 should give us the sector area, which they tell us is 16 pi over 3. Okay, so I have to go kind of backwards and find theta. So how do I get rid of all this stuff and get theta by itself? How do I get rid of, you can get rid of the 360 first or the 16 pi first. How do I get rid of 16 pi? Yeah, when you divide by 16 pi, what you're really doing, dividing by 16 pi is the same thing as multiplying by 1 over 16 pi. So what happens is those, remember multiplying fractions, those will cancel out. So we got like a 1/3. So we have theta over 360 equals 1 over 3. How do I get rid of the 360? This is theta divided by 360. So multiply by 360. I'll just put, times 360. What's 1/3 of 360?
120.
120. So theta is an angle, so it's 120 degrees for that answer. Okay, number 17. This time we don't know the radius, so the pi r squared part we don't know. We know the central angle is 180, so that's 180 over 360. You guys know what that reduces to? 180 over 360? 1/2, yeah. So I could, I'll simplify that in a second. And that's supposed to equal the sector area, which is pi over 2. That's what the book told us. The book gave us theta, the book gave us the area. They didn't give us the radius. So this simplifies to 1 over 2. So I could rewrite this as 1/2 pi r squared equals pi over 2. Okay, how do I get rid of the 1/2 and the pi? I'm just trying to get r here. How do I get rid of these two guys?
Divide.
There, yeah, they're both multiplied to r squared, so I need to divide them. When you divide by 1/2, that's the same thing as multiplying by 2 over 1. So what's going to happen is those go away, and when you divide by pi,
So radius equals.
it's like times 1 over pi, so the pi's go away. So r squared equals 1 over 1. R squared equals 1. And if the radius squared is 1, what's the radius? Yeah, the square root of 1 is 1. Okay, 19 is asking for two answers. It's asking for the sector area and something they call the segment area. I'll explain what the segment area is in a second. So the sector area is going to be, so they made it a triangle right there, but the sector area is going to be all this stuff, basically. So we're just going to use the sector area formula. What's the radius for number 19? 10. So I'm going to do 10 squared times pi. What's 10 squared?
100.
So I'll just call it 100 pi. And theta, what's the central angle on this one? 90. You guys know what 90 over 360 reduces to?
1/4.
1/4. You don't really have to reduce it. You could plug this in, but what's 1/4 of 100?
25.
So 25 pi is the sector area. I guess it's miles? Yeah, square miles. That would be one of our answers. Okay. They also said find the segment area. What they mean by that is, I don't know why they called it segment area, I really don't get it at all, but what they mean though is this gap that's between the chord and the arc. So any ideas how we can find that green area right there?
Subtract the
Sector. Subtract the,
sector from the other triangle.
yeah, sector area, like that red stuff that we just found, minus the triangle area, and what does that leave us with? This gap right here. So we're going to take all the sector area, which is that thing, minus the area of the triangle, and that will leave us with the leftovers, the stuff in here. So how do I find an area of a triangle?
Base times height divided by
Right, so the base and the height are
10.
10 and 10, because they're both radii, so they both have to be 10. So 10 times 10 divided by 2 is 50. That's the area of the triangle. So we want to do sector area minus, by the way, 25 times pi is actually bigger than 75 because that's bigger than 3. minus 50. We could leave it like that since it doesn't simplify, but let's go ahead and change this to a decimal and then we'll call it good. That comes out to about 28.5 square miles. Got about 12, 11 minutes. You guys work on that. Any questions?